Dear conference participants, the development and effective application of fog computing technologies require the most complex tasks related to the management and processing of huge data sets, including the task of rational construction of low-level networks that ensure the functioning of end devices within the IoT concept. In our article describes the use of graph theory methods to solve such problems. The concept of fog computing, in contrast to cloud computing, involves the approximation of data processing to the end devices of networks, computers, mobile devices, sensors, and more. Graph theory is used to construct a load balancing algorithm for fog network computations based on a dynamic graph distribution that the fog cloud automation computing system can flexibly build a system network, and the dynamic load balancing mechanism can efficiently configure system resources as well as reduce the consumption of node migration caused by system changes. Some authors propose a fog network caching scheme based on the Steinef tree, in which fog servers, batch caching resources, first create a Steiner tree in graphs to minimize the total path, weights, or cost, so that the cost of resource caching with the tree can be minimized. Chen and Zhang propose a hybrid high-fog system for unloading tasks in fog computing based on a tree-level graph for efficient distribution of tasks between devices. The problem of minimizing the total cost of the task is reformulated as the problem of the minimum weights ratio in the constructed three-level graph, which can be effectively solved using the Blossom-Edmonds algorithm. Techimansky describes a set of 300 pseudo-random task graphs which can be used evaluating mobile cloud, fog and edge computing systems. The pseudo-random task graphs are based upon graphs that have previously appeared in the IEEE papers. At first, when modeling the operation of both individual elements and the system, designed and/or built on the concept of fog computing as a whole, for example, to access efficiency, performance, bandwidth, equipment, reliability, the delay time for certain types of service, data, software, the system should be presented in the form of several interconnected levels. Equipment, interface, transport system, network, operating system, OS, data, services, applications. Such a representation of the object of modeling allows you to use the apparatus of graph theory. Slide 2 in the form of an oriented G equals ZL presents a multi-level graph model of the system built according to the concept of fog computing. The set of vertices of the graph are tasks that are solved at each specific level. The set of arcs contains the set of parameters needed to solve these problems and the set of information links. The set of parameters XPR consists of input and output parameters. It should be noted that the output parameters of some task vertices may be input for others. Information connections are converted into a Boolean matrix n times n. The matrix elements HGL characterizes the presence of information connections or problems G and L. The solution of any problem can be represented as formula on the slide. An example of the task are solved at first level equipment in the calculation of reliability and performance of devices. The second level interfaces. As mentioned above, for calculation are best suited for working with inner machine interaction system M2M, machine to machine, and devices that use a human-machine interface. Third level, transport system network. As the tasks are solved at this level, it is possible to result in the following: a choice of communication channel, channel bandwidth estimation, calculation of the delay factor of network equipment, estimation of message delay, and many others. Level 4, operation system OS. Here you should consider the presence of different types of operation system: Unix-like OS, Windows, OS X, etc. The vertex ZOS of the graph describes the general task characterizes of the OS level. Level 5, data. Examples of tasks to be solved at this level: prognostic calculation of the speed of new data generation, optimization of file placement and processing of requests to the database, estimation of data volume, data compression. Level 6, services. Example of tasks: calculation of productivity for the 6th level, assessment of service quality in virtual VPN channels, optimization of system services by network resources. Level 7, applications. Applications are research software, computer-aided design system, games, application for artists, geographically distributed application for pipeline monitoring, smart devices in the car, smart grid, traffic light control system. Some example of tasks: distribution of application tasks between users according to the criterion of weighted average road length, prognostic estimate of the conditional average service time of the application required to perform the task lasting in NT period, estimation of the average time of the decision of applied problems, calculation of exchange time with external memory in the process of solving applied corporate tasks. The main properties of the multi-level graph model for computing are shown on the slide. Secondly, our paper shows how to plot graphs and then customize the display to the add labels or highlighting to the graph nodes and edges of pseudo-random task graphs, which can be used for evaluating mobile cloud, fog and edge computing systems. The graphs are described and visualized in MATLAB code. We used a set of pseudo-random task graphs which can be used for evaluating mobile cloud, fog and edge computing systems. The pseudo-random task graphs are based upon graphs which have previously appeared in the literature. Researchers can analyze with 300 task graphs and their own configuration of a mobile cloud, fog and edge computer system with different mobile device parameters and cloud, fog, edge, server parameters, but the code does not provide the ability to visualize graphs and properties of nodes and edge. Each task has an amount of computational work to perform, expressed in megacycles per second. Each edge has an amount of data to transfer between tasks, expressed in kilobits or kilobytes of data. The set can be used by researchers to evaluate cloud, fog, edge computing system and computational of loading algorithms. The task graphs can be used as a single-user system where one mobile device accesses a remote server, or a multi-user systems where many users access a remote server through a wireless channel. Graph plots are the primary way to visualize graphs and networks created using the graph and digraph functions. After you create a graph plot object, you can modify aspects of the plot by changing its property values. This is particularly useful for modifying the display of the graph nodes or edge. Graph plot properties control the appearance and behavior of plotted graphs. By changing property values, you can modify aspects of the graph display. Use dot notation to refer to a particular object and property. Let's plot a graph by marking the edge with their weights and making the width of the edge proportional to their weights. Use a scaled version of the edge weights to define the width of each edge so that the widest line has a width of 5. You can see some examples on the slides. Thank you for your attention. We will be grateful for your questions.